Students, in the last video lecture, I just gained some brief concepts regarding this optical fiber communication system. So I just have given the list of textbooks which are required for searching the topics of this optical fiber communication system into those books. So three books I have given. Therefore, you just go through all those three books, and similarly, I just have given some introduction which are something basics in the case of optical fiber communication system, I can say. And so I said during then I said the evolution of the optical fiber communication system, and I said that optical fiber cables were there during 1950s and 1960s. However, the detonation of those optical fiber cables is very high when compared to the attenuation of this coaxial cable. Coaxial cable used to provide attenuation which is around 5 decibels per kilometer, whereas the optical fiber cables used to provide attenuation which is greater than 5 decibels per kilometer, or I could say that the attenuation of that optical fiber cable is around 10 decibels per kilometer. So this is said to be the huge attenuation that these optical fiber cables during 1950s and 1960s used to provide. Therefore, during 1950s and 1960s, optical fiber cables were kept aside. So optical fiber cables are not in the usage because of the only disadvantage in terms of the attenuation. And during a span of 10 years or during a decade, these optical fiber cables have been designed in such a way that the attenuation of those optical fiber cables have become very least significant. And so what I mean to say is attenuation of those optical fiber cables uh, have become a value which is less than 1 decibels per kilometer. So attenuation is the function of wavelength. So I don't discuss the dependency of this attenuation on wavelength in this unit 1, but in the coming units I just discuss how this attenuation is being dependent on the wavelength. So one simple diagram is there, so that of that diagram we could give this conclusion. And similarly, I said that in this optical fiber cable, two materials have been involved. So those two materials are said to be the core, and the other material is said to be cladding. I know that these points you could have got in your engineering physics as well as in your plus two also. So core is there and cladding is there. So both of these are said to be the materials which are being used for the optical fiber cable fabrication. Against, and these are the different materials. Therefore, any of the material has got the refractive index, and here in the case of optical fiber cable, core refractive index is high when compared to the cladding refractive index. So if I assume N1 as the core and N1 as the core refractive index and N2 as the cladding refractive index, then I said that in order for the light pulse to propagate into the optical fiber cable, always core refractive index should be high when compared to the cladding refractive index. So if we think that cladding refractive index is high when compared to the core refractive index, then in that case it is not possible for this light ray or light pulse to stay within the core part. It just comes out of the core part and will not be delivered at the receiving end or at the destination, I can say. Therefore, this is said to be the basic thing that we need to remember in the case of optical fiber cable. And in this class, what I do is I just move on to the elements of the communication system, which is said to be the first topic in this unit one. And before going to discuss these elements of the communication system, so let me focus on the electromagnetic spectrum within which we just assign the frequencies of this optical fiber cable. So I said one advantage of this optical fiber cable in the last video lecture, and I said the major advantage of this optical fiber cable is the bandwidth, and the bandwidth ranges from 10 power 11 hertz to 10 power 14 hertz. Therefore, bandwidth always be expressed in the powers of tens only. Therefore, so in order to choose higher frequencies, we need to choose these from the top three bands. If you take this electromagnetic spectrum, then this electromagnetic spectrum has got a total of nine bands. So let me show the electromagnetic spectrum to you people. This is what the electromagnetic spectrum is. So if you see this electromagnetic spectrum, so on the top side, three bands are there, and on the bottom side, six bands are there. Therefore, three plus six gives us nine bands. Therefore, in this electromagnetic spectrum, a total of nine bands have been existing. So the lowest band here is said to be the audio frequency band, and the highest band is said to be ultraviolet. So therefore, if you say this electromagnetic spectrum, so this has got three columns. So the first column is said to be designation. So second column is said to be the transmission media, and the third column is said to be application. So these are said to be the three columns which have been given in this electromagnetic spectrum diagram. And therefore, so look what I do is I don't focus on the bottom six bands because the frequencies of these bottom six bands is less when compared to the frequencies that these top three bands have been existing. So if you see this automatic spectrum, so here right side frequencies have been assigned, and similarly to the left side wavelength has been assigned. Wavelength left side of the frequency, right side of the day. So we know that there exists a relation between wavelength and frequency, and that relation is lambda is equals to c by f, or f is equals to c by lambda. Therefore, it is clear that the wavelength and frequency, both of these are inversely proportional. Therefore, if you see this frequency, so if you take the frequency in the bottom side, so in the bottom side, the frequency is said to be 1 kilohertz, and if you move from bottom to top, then the frequency is there, so that frequency has been increased. So when the bottom side frequency is less, and that frequency is to be 1 kilohertz, whereas the top side we just have got the highest frequency, and that highest frequency here is being shown as 10 power 15 hertz here. And similarly, if you take this wavelength, and so if you take the same wavelength in the bottom side, so on the bottom side, I just have got the highest wavelength, and that highest wavelength is said to be 100 kilometers. So frequency here is said to be very less, and that frequency is said to be 1 kilohertz, and here wavelength is there, so that wavelength is said to be 100 kilometers, which is far high when compared to the wavelength that the bottom three bands are being holding. So if you say the wavelength here, so wavelength is there, so that wavelength will be is been existing in terms of negative powers of 10. So here you just have got 1 centimeter as the wavelength to this millimeter waves, and if you move a bit up over to this millimeter wave, so you just have got the wavelength which is even less than 1 centimeters. So this clearly indicates that the wavelength and frequency are inversely proportional. Therefore, so I said that the bandwidth of this optical fiber cable is very high, and the reason for higher bandwidth of this optical fiber cable is because of choosing these top three bands only. So if you see these top three bands, so here the first band is set to be ultraviolet, second band is visible, and third band is set to be infrared. Therefore, this ultraviolet is there. So this ultraviolet is said to be a band which has got shorter wavelengths, and similarly, infrared is said to be a band or a region which has got a longer wavelength. And similarly, visible is there. So visible is said to be a band or a region whose wavelength will be in between this ultraviolet and infrared. I said that infrared has got longer wavelengths and ultraviolet has got shorter wavelengths. Now, in another way, also we can able to define these bands. Ultraviolet region or ultraviolet band is said to be the band to which ultraviolet region or ultraviolet band is said to be the band which has got shorter wavelengths, and human eyes cannot able to respond to this shorter wavelengths. Human eyes are not going to respond to this shorter wavelength, hence the band called as ultraviolet is being named here. And similarly, here we just have got infrared, and in the infrared I said that longer wavelengths have been existing. So even to these longer wavelengths also human eyes cannot able to respond. Therefore, this band, I mean infrared band is said to be longer wavelength band, and ultraviolet is said to be shorter wavelength band. So shorter wavelength I have said. So it means that the wavelength of this ultraviolet is very less when compared to the wavelength of this infrared. So what I mean to say is what I mean to say is all these three bands have got some wavelength ranges. So if you say this ultraviolet wavelength range is said to be 100 to 400 nanometers. This is said to be the wavelength of this ultraviolet, whereas to the visible wavelength is said to be 400 to 800 nanometers. That is said to be the wavelength range for this visible, whereas for the infrared wavelength range is said to be 760 nanometers to 1 millimeter, I can say. So this is said to be the wavelength range of this infrared. So again, this infrared has got two regions. One region is said to be the region which is very much close to the visible, and that region is said to be near infrared. And that near infrared has got some wavelength range also, and that wavelength range is said to be 800 to 2500 nanometers. And similarly, so one more part is been existing to this infrared, and that part is said to be far infrared. And this far infrared has got the wavelength, and that wavelength is said to be 2500 nanometers to 1 millimeter. Therefore, you remember that we just choose the bandwidth of this optical fiber cable from the least portion of visible and from near infrared, I can say. So we just take a minute portion of visible and we just take this near infrared. Therefore, if you see a dotted line which has been shown here, so this dotted line indicates the bandwidth for this optical fiber cable. And in the case of optical fiber cables, instead of using the word called as frequency, we just use the word called as wavelength here. Therefore, instead of expressing the, instead of expressing the frequency, we just express the wavelength here. Therefore, so here the extreme left limit is being shown, and that extreme left limit is said to be 800 nanometers. And similarly, extreme right limit is being shown here, and that extreme right limit is said to be 2.55 micrometers. So if you want to write this in terms of nanometers, then what would be the value? So what you have to do is you need to multiply this 2.55 micrometers with 10 to the power minus 3, and similarly the same should be divided with 10 to the power minus 3. So 10 to the power minus 3 is going to flip up. You just get 2550 nanometers. Therefore, range here is been shown as 800 to 2550 nanometers. However, in your textbooks, we just discussed those optical fiber cables which has got a 800 to 1600 nanometers wavelength. So this point is again something important, I can say. So 800 to 1600 nanometers is said to be the wavelength range of this optical fiber cable that we are going to discuss in all these three, in all these 5 units here. So therefore, you just remember this. So with the help of this optical fiber cables, we can able to transmit voice signals or telephone signals. We can able to transmit plain data. We can able to transmit this video signal also. So here, this frequency range is there. So that frequency range has been expressed in terms of powers of tens only. And similarly, and so after that, let me discuss the bottom six bands briefly. So here you're finding millimeter waves, super high frequency, and ultra high frequency. These are the three bands that you're finding here. And for all these three bands, applications are said to be navigation, satellite to satellite, microwave relay, earth to satellite, radar, and UHF TV. Therefore, for all these three bands, the frequencies will range from 1 gigahertz to 100 gigahertz. And similarly, for the next three bands, the applications are the next three bands are said to be very high frequency, and medium frequency. So for all these three bands, applications are said to be mobile, aeronautical, business, amateur radio, international, and citizens band, and FM as well. So all these are said to be the applications of these three bands. And one point that you need to remember is, in order to transmit these frequencies, we have to use these coaxial cables only. That's why here in this electromagnetic spectrum, the second column is a TV transmission media or transmission channel, whereas in order to transmit this UHF, super high frequencies and millimeter waves, we need to use a metallic enclosure, and that metallic enclosure here is said to be a waveguide. And similarly, and so after this, we just have got bottom three bands, and those bottom three bands are said to be low frequency, very low frequency, and audio frequency. So to transmit these low frequencies, either we have to use this wire pairs or simple copper wires we could also use. So in some other books it has been mentioned as twisted wires also. Therefore, for all these three low frequencies, applications are said to be telephone, telegraph, transoceanic radio, navigation, aeronautical, and submarine cable, I can say. So if you see this electromagnetic spectrum diagram, so he has mentioned some waves also. A total of three waves he has mentioned. So the first wave is said to be microwaves, second waves are said to be short waves, and third waves are said to be long waves. Microwaves are said to be those waves whose frequency range is 1 gigahertz to 10 gigahertz. So sometimes we just take 30 gigahertz also. So that is said to be the frequency range of these microwaves. And similarly, if you take these short waves, the frequency range is so that's that frequency range is almost or around 5 megahertz to 10 gigahertz, I can say. And similarly, for the long waves, the frequency range is said to be 10 kilohertz to 5 megahertz, I can say. So this is said to be the electromagnetic spectrum that I just want to discuss in this video lecture. This diagram is there, so this diagram is very important for your exam exam. So many times this question has come. So what you have to do is your if a question comes on this electromagnetic spectrum topic, then in that case you need to write the importance of bandwidth in this optical fiber cable, and along with that you need to focus on the top three bands in which the frequencies will be chosen for the optical fiber cable. So hope that you just remember all the values that I have said in the explanation of this electromagnetic spectrum. So bottom six bands are not that much important, but top three bands are there. Those top three bands are very important in the discussion of this electromagnetic spectrum. So this is what the topic that I just want to discuss in this video lecture, and in the next video lecture, what I do is I just discuss the elements of a communication system. So hope that you remember the block diagram of conventional communication system. So we know that in the conventional communication system, three basic blocks are going to exist, and those are said to be transmitter, communication channel, and receiver. So also in the case of optical fiber communication system, also we just find the same three blocks. Along with these blocks, we need to use two more blocks, and those are said to be the optical source, and we have to use this optical source at the transmitter end, and along with that we have to use this optical receiver, and this optical receiver has to come at the receiving end. And so you remember that for this optical source or for this optical detector, we need to use this drive circuitry, and that drive circuitry is said to be electrical transmit and electrical receive drive circuitries. So these are said to be the drive circuitries in which the modulation takes place, modulation and demodulation, I can say. So probably in the case of optical fiber cables, we just use a distal modulation technique, and that is distal modulation technique is said to be amplitude shift gain. ASK is that this ASK is more significant in the case of optical fiber communication system. Therefore, for time being, you just remember this electromagnetic spectrum block diagram, electromagnetic spectrum diagram, and in the next video lecture, we move on to the block diagrams of, block diagram of this optical fiber communication uh, system, I can say.